Uh, Good afternoon, everyone. First of all, thank you for being here. It's such an honor to share this stage with such a forward-thinking and enthusiastic audience. A quick introduction about me. Um, my name is Naresh, and I have 15 years of experience in enterprise data applications. I work for the various financial and telecom organizations in building the real-time analytic applications. I have more than half a dozen of certifications on the cloud and the Kubernetes, and I have a bachelor's in the computer science and technology. And having said that one, I would like to quickly jump onto my talk today, that is improving the real world RAG systems, key challenges, and the practical solutions. So let's first understand the RAG system for the benefit of those who may not know. So RAG system is a nice way in which you infuse your custom enterprise data and give it to a large language model to augment its knowledge base so that it could answer to your questions more contextually relevant. If you look at the RAG workflow, it's basically a two-step process. And the first step is like you prepare the data and index it, where you take your data, split it using some different splitting strategies, and then you generate an embeddings for those chunks, and then you put it into a store kind of a database called the vector database. That's the process is called the uh, indexing. That's the first step of the RAG system. The second step of the RAG system is that RAG workflow is the search and the generation, where you ask the question and you retrieve a certain documents from the vector database, and then you you combine these questions, the retrieved documents, and you kind of form a prompt, and then you give it to the LLM that generates an answer. It's all the overall the RAG flow. That's what the RAG. Today, let's see what are the key challenges and practical solutions that I have been implemented over a period of time in the last 18 months. So if you see this one, it's a typical RAG workflow. The top part is in the indexing part, and the bottom part is in a query and response generation. If you see the red boxes, those represent the uh, failures points or the pain points in any typical RAG system. Of course, there could be a more pain points or failure system, but most of these are the primary failure points in any RAG system that you take. And the first one is the top one is the missing content. It's because of the data may not available to answer your question. And the bottom part is sometimes your query generation, retrieving the document, there could be any issues, and there could be any that falls under the missed tab ranks and not in context or incorrect specificity. But there sometimes you have the right data, but you are not able to generate a right answer using these LLMs. That includes the wrong format and incomplete. We'll go in detail of each of these and how to tackle these pain points in a real world. So the first problem statement is that a missing content. So it means that answer to your question to answer your question, that the documents required to answer your question is not available on your database. So that leads the LLM, these language models, to answer very confidently a wrong answer. That's what the people call the hallucination. And that ends up your end users being frustrated with the irrelevant or wrong responses. The way to solve this challenge is there are various ways, but these are the primary ways we can implement. So the first one is the better data cleaning, where you can, it goes by the principle of the garbage in and garbage out principle. So if you have a better quality data, then the possibility to get a good embeddings for your data, and that will give you the good responses, good results to you. So sometimes we don't want the wrong answer, the models to generating an incorrect answer, then we can go for some kind of constraints on the prompt that will help us to not generating any irrelevant or incorrect answers in case of the data is not available in the database. And the third one is the most famous one we might have hearing in the agents in the last few months. Uh, Agentic RAG with the search tools will help us to get the information from the outside of your database and get the information to answer your questions in case of the data is not available. That's here is a, let's quickly see one example of the RAG. If you see that if we are saying that you are a RAG, you can help with the question answering system. And in the bottom, in the middle part of the slide, you see that one I am providing some context saying that who is the winners of the Cricket World Cup and T20 World Cup. And then I'm asking a question that is not related to the cricket. I'm asking a question on the soccer or football, right? So it's, if you see that in the bottom part of the slide, it is able to generating an answer because it's not that model is trained on this data already, so that's how it was able to generate an answer. But if you see it in the context, we did not provide any information about the soccer champion or Euro championships. So to address these kind of problematic RAG prompt, we could add some kind of constraint saying that if you don't know the context, not have any information related to the question, just don't make up the answer. So this is the one way to we can reduce the hallucination or constrain the model not answer a question that is information that is not available in your vector store. So the third approach is like an agentic RAG with tools. So agents is basically, if you ask me, agent is combination of a LLM, prompt, and tools. So these prompts instruct the LLM to understand which tool to use to get the information or solve a specific problem. And these tools are something we need to code it. We'll see quickly in how we can build an agentic RAG here. If you see here in the top part of the slide, we built a search tool where it will allow us to go and search in the internet and retrieve the information from the internet. And in this middle part of the slide, where we combining the search tool that we have it with the LLM, so that LLM can use that tool. And in the bottom part of the slide, we are mentioning that in the prompt, if you could not find the information that you are looking in the data store that you are retrieving, you can see that see if you can leverage one of the tools that is at your disposal so that you can get the information from it. With this setup, if we ask the same question that we asked in the previous slide, then if you see in the bottom part of the slide, we are able to see that it making a function call, like internet call to the search the web and get the information from the web and able to answer it. So these are the three ways of we can solve an document data that is missing in your content, in your data stores. So the next problem statement is missed top ranks. I combined these 3 to 4 problem statement together, and then I will provide answers in a, we can tackle them in one using one solutions. So Mr. Top rank means that to answer your question, it has a documents available in your store, but when you retrieve it, you are not able to get it. Let's say it may be the bottom record in your bottom document in your search results. Then you may there is a possibility that you will miss that record because of some various reasons, and that will lead you to model not able to answer it. So here, basically, the document to answer the questions are present, but fail to retrieve due to the poor retrieval strategy or cleanup or something. Some kind of sophisticated mechanism we put it there because of that, you are missing the data. So the other problem statement is that not in the context means that the documents with the answers are present during the initial retrieval. When you retrieve it, you got the documents, but you have some kind of re-ranker or consolidator. And when you make it to the final context that is required to generate an answer, there could be a possibility that you will miss out those documents that help you to answer the question. So other challenge is that let's assume that you retrieve the document and this document might have a lot of information, the contradicting information, more noise in that information, then that will make struggle your model to not to answer, get the relevant information to answer it. And the other challenge is that incorrect specificity means your output response maybe is a too vague and is not detailed enough or specific enough. So it basically because of your question wording may be the too vague that results in the too vague retrieval of the documents from the store, and then that will create that will creating not generating an answer in a right way that you are expecting. And the reason for this one could be the wrong chunking or bad retrieval. Any of the things can be possible. Any of those can be the reason for the incorrect specificity. So the way to solve these problems, all these is like use the better chunking strategies. There are various chunking strategies available for us to understand, break your data so that you get a better results out of it. And the second one is a hyperparameter tuning. This is one of my favorite one. Most of the people will not try this one. We should try with the different parameters tuning so that you will get a better results. And the third one is a no-brainer. It's using the better embedding models. The latest embedding models are trained on the good latest data so that they may perform very well. And the other one is use advanced retrieval strategies. When you build your RAG, you'll use the tools and frameworks, right? Don't go by the default settings of those tools and frameworks. Try to make those changes in those tools so that you can get a better uh, responses. And the other one is the context compression. So if you have generated a lot of information, there is a way to reduce that information before you give it to the model to generate an answer that help the model to understand the content very quickly and generate a good answer for you. And the last one is the better re-ranker models. Again, these are like the better embedding models. They are trained on the latest data and they are trained on the latest cutting edge technologies. So the solution is like, if you see that we have a various chunking strategies here from top to the bottom. The bottom one are a little expensive. They may cost you uh, some tokens, but they give you the better results. The top four, three or four are like the some basic chunking strategies that don't cost you more, but they may not give you the better results for your rack systems. And in the bottom two, like the semantic chunking and agentic chunking is where you put an LLM in action to do the chunking for you so that that there may be possibility that your LLM cost may go up a little bit. The other one is a hyperparameter tuning in the chunking and retrieval strategies. So if you see that one, assume that you have some human generated answer and you put those, you have a documents and then you are generating an answer using your RAG systems. Then you can compare the the golden answer with the RAG system generated answer so that you can compare. When you are doing that, when you are generating the answers, you could try with the different chunk sizes like 500 or 1000. That will help us, and you can find for each chunk size you might get the results, and then you can compare the results that you got it with the golden results you have it. And there are various evaluation frameworks available for you to evaluate and see that whether it's able to generate an answer to your most matching to your golden answers. And there are other techniques like the top K or similarity threshold, saying that don't retrieve the documents. Those are similarity threshold like 20% or 30 percentage low. Just get the documents that are more than 60% that help you to answer. These are the some of the parameters we can try it out in the RAG systems. And the other one is the better embedding models. MTEB is a massive text embeddings leaderboard where you find the latest embedding models. And these are the benchmarks you might see. Take them with a pinch of salt. And always the better embedding models will give you the better results. So, but always you need to experiment with your embedding models. But the embedding that MTEB board is a way for you to find out which embedding model to pick for you. And the more you experiment with your data, there may be the other models, those are not in the top, may give you the better results. So it's always better to experiment with your data. Sorry. And other thing is that do not use the commercial models, because With the commercial models, you need to send your data to uh, the OpenAI like kind of providers. So you have to send it to their servers. So if the privacy is more important, try to go with the open source models or in-house model that you can run it on your data centers. So the other one is an advanced retrieval strategies. If you see in the diagram, so the first one, number one, is a basic similarity similarity one, where you are using the cosine similarity or kind of things. The other approach is like you can use the other similarity techniques other than the cosine similarity that will that may give you the better results for you. And also having some threshold, like don't get the results less than 20% or 30%. That's what you are seeing in the second item in the slide. So other technique is that multi-query retrieval, where you give your query to the LLM and ask it to generate a various versions of the same query. So these various versions of the same query help us to retrieve the more documents, more contextually relevant documents from your vector store, so that you can combine all those documents and you can use those documents to generate a final answer. So the other technique is a hybrid search, is a combination of the keyword search and semantic search. Let's take an example of you are looking for some kind of RAM or processor. When you are doing that, the RAM model, the processor number, RAM size, these are matters for you, right? So in those cases, you can go for the keyword search that matches by the keywords. And the semantic search is the similarity search. Similarity search is like the cosine similarity or any other sophisticated similarity techniques. And the keyword search is in a BM25 is in the most TF-IDF. These are the techniques you can combine them and generate a combined data sets while generating a final response. That's what you are seeing as in number 5. And the fourth one is a re-ranker. So re-ranker is the way you give your documents to the re-ranker model that will rank those documents, whether this document can answer your question or not. It is not like a similarity, it's a relevance check. Relevance check is different from the similarity checks. Relevance check will basically tell us like whether this document can be used to answer your question. So that's what the relevance checks. And the last one is the chain retrieval, is like something you can combine all of those techniques that we discussed in the top, so that you can chain them and get a better results for your RAG system. This is the re-ranker models. Like these are flow where you can introduce a re-ranker. Once you get the documents from your vector store, then you can send those documents and the query to the re-ranker, and that will return a score. Using that score, you can decide whether you wanted to consider the document or not in your final response generation. There is another technique is called the context compression strategies, where you try to reduce the amount of information that you send to the model. There are various ways to filter out, like the LLM prompt based context compression, or Microsoft LLM Lingua. That's another model available for doing the context compression. There are two ways to filter out the content. One is like you can filter out the content that is not related to your question. That is what they call the extractor. Or else you can filter out the entire context documents. Those are not related to the your question. So these are the two different ways to reduce the information that you send to your model. If you see here, I'm giving an example of what is the capital of India. When the semantic search returned the three results, Delhi is the capital of India, and Mumbai is the financial capital, Kolkata is the world capital. But when we do the contextual compression, we are getting only the Delhi is the capital of India. So that is how we can reduce the amount of information that we are sending to the final LLM to generating an answer. So the other challenge is the wrong format. Wrong format is like the response generated by the model is not the one you expected. Like, for example, you wanted the response to be generated in a JSON or XML file, but the model is not able to do that one. This will happen most of the times we are using models. Those are trained on the less data. They have less features. If you use an OpenAI or Gemini, Google Gemini, they have an inbuilt mechanism to generate a response in the format that we are expecting. So the other the solution for this wrong format is like again there is no brainer on the first one, using the powerful LLMs like the OpenAI, Gemini to generate a response in a format that you wanted. And there are prompts, better prompting and output parsers available. Those also you can use them. And there is a set of structured output frameworks also we can use that for generating the response in a way we wanted. Here is a quick example of, here we are providing you're using an OpenAI Gemini GPT-4 mini, and we are mentioning that generate the response in a JSON object. And also we need to tell that in the JSON object, what are the fields need to be there. So we gave a prompt and saying that we wanted the win team, lose team, venue, date, score. These are the fields I wanted generated in my LLM response. So that's how we were able to generate JSON response out of the uh, LLM response. So the other solution is like there is a lot of frameworks like the LangChain, Llama Index. They are allow you to, they gave a lot of parser out of the box to parse the LLM response, raw response, and generate the content in a way that we consumable for the downstream consumers. And the last one is like using the structured framework, output framework. I have used some of them like the instructor and the fructose is something I used in my one of my previous projects for generating the response in a way that I wanted. And the other problem statement is that incomplete means the generated response is not complete. It could be the various reason, because of the bad retrievals or bad retrieval or bad reasoning, or there is not enough context available in your store to answer your question. So the solutions to them is like, again, the first one is using the better models, GPT-4 or Cloud or Llama 3 these days is giving a better results. And the other one is like using the building an agentic system with the tools that we have seen one of the previous slides. And other techniques are like using some of the chain of thought, self-consistency. These are advanced prompting techniques we can use to generate a complete response. And the last one is the hide. This is a rewrite your user query to improve the retrieval. This is something I have implemented, and this idea is from one of the research paper that available on the internet recently. So in the hypothetical document embedding, what we will do is that we will give the query to the LLM and ask to give a hypothetical answer to the questions, so that it will give a set of hypothetical answers to the questions. If you look at that one, a question is maybe a few words, but if you see that answer, it could be a more words, right? So we are using these more words to retrieve the more relevant content from the vector database. It's not always it will work, but there are some use cases that may work for that your use cases may work for this approach. So use those hypothetical embedding documents and retrieve the results, and use those retrieved results to generating your final response in your RAG prompt. So that this might give you the better results for some of the use cases. So other practical solution from the research papers, which actually will work for you, is RAG versus long context LLMs. With the Google Gemini, it's like 1.5 million tokens or something. It's going exploding the context length, right? Of course, these long context LLMs always outperform the RAG because they have an entire information available to answer the question, but they will cost you the more money and more tokens. That may not all organization ready to offer it. If you look at this paper, they have some metrics saying that which one is doing the better, like the long context versus RAG. And of course, the long context will always works better than the RAG systems. But how about there is a way like you can combine the long context LLM with the RAG as a hybrid approach to answer your queries. So the architecture is like this. So you ask the question and you get some documents, and you give those documents to the LLM and ask the LLM, these documents can be used to answer your query. So the LLM will tell that whether this answer is answerable or not. Depends on the decision. Either you can go for a standard RAG flow, or else you can combine, you can take the entire document that you have available for answer that question and send that entire document to the LLM to generate an answer. So this is the way you can hybrid way you can reduce the cost of your LLMs. And the recent LLMs are they are having features of hallucination checks when you are using them. So the GPT-4o have some hallucination checks available, and the links from Paternos AI has a prompt-based hallucination checks available. So here I put a research paper that they really available on the internet so that we can read more about it. And the key takeaways from that my entire talk is like RAG is still very much a retrieval problem. The better the retrieval, the better the answer generation. The second one is build an evaluation data set. Always evaluate your RAG systems so that you can find out which combination of the which settings will work for your RAG system. And explore the various chunking strategies and retrieval strategies of the tools that you are using and the framework that you are using. And the other one is like even with the long context LLMs, RAG is not going anywhere for now, at least. It still be there. And the other approach is like go for an agentic RAG system with the domain specific fine-tuned RAG system or the future, at least for the next couple of years on the RAG application development.